am starting the recording now, and we're just ending this poll, which I'm going to close and then now share. So you'll see some of the responses of the attendees here. And Azure ML Service is one of the newest things. And so not surprised that many people want to see more about what that's doing. I continue to learn more myself. I am not on the product team at Microsoft. I work in a different area. I'm a user and I'm customer facing. So that is the poll for today. And so we'll hide that as we go into our main deck. So now we'll start the presentation overview of Automated ML, June 2019. I'm Mark Tabladillo. I am a data and AI scientist at Microsoft and a cloud solution architect working in the US CTO Customer Success Office. You can find out more about me at Twitter, marktab.net, and also on LinkedIn. The agenda today, we are going to do why automated machine learning. Secondly, Azure ML Service and Azure Databricks. Third, capabilities, what's new. Fourth, demos. And finally, finishing with enterprise deployment. On Azure, we have a number of technologies that are available. We will only be seeing certain ones of them today. Specifically, we'll be focusing on Azure Databricks and Azure Machine Learning. But of course, there are many other technologies. Some of them are proprietary to Microsoft. A lot of them are open source technologies, and you'll see some open source technologies like TensorFlow and Onyx is there, and then also some hardware options. So many other things available. Here are some of the companies that are using Azure for machine learning and AI, and many of these organizations are sharing their stories, telling their stories. We love to have customers tell their stories with how they're using the technology, what is powerful about it, and would love to have you tell your story too, whether in presentations or sharing that with Microsoft. Why automated machine learning? Okay, so we do have so many of these tools. We know that they're out there, and we're now at a place now where we're thinking about the future, and we're thinking about building blocks for a data science project. We have this process that we go through starting on the left side with data sources, then we go to classical machine learning, or maybe we're doing deep learning, hyperparameter tuning, experimentation pipeline, deployment, and DevOps. And when we're in that CI/CD cycle, we're iterating back around again for more building and training models. The automated ML technologies that we'll cover today, they provide a look into how to do this model building more efficiently through the Azure portal. I'm going to start with this one. And we have here, what is automated machine learning? And the three things we want to focus on are feature engineering, algorithm, and hyperparameter selection. So the automated ML mission is to democratize AI, accelerate, and scale. We're going to do a problem of how much this car is worth, and it's going to show what features on the top. Okay, you see the little graphics there? And we might choose an algorithm. In this case, we're going to first choose the gradient boosted, and then we're going to choose what parameters to use, and we might get 30% as a output. And then we do it again. And then you see in the second one, we're in the iteration, we're doing nearest neighbors, and then we have 50% showing on the right side. But then we run it many, many times and decide that 95% was the highest number for that particular run. Let me click forward again. So the idea here is to have entered data, define goals, your constraints, and you want to intelligently test multiple models in parallel to find out which is the optimum model. The automated ML capabilities are based on Microsoft research, and so what this is saying is what the parameter type of searching pattern and what algorithms to use and what type of things to do to features. All three of those ideas were curated together as part of this automated technology over time, and brain trained, they call it brain trained with several million experiments to come up with this technology. So this is where this technology is coming from. The automated ML capabilities scenarios are classification, regression, and forecasting. The languages are Python SDK for deployment and hosting for inference, Jupyter notebooks. The training compute can be done local machine. The reason it can be done local machine, even though these algorithms were developed in the cloud, they actually run on where you say they will run. Or they could be Azure Machine Learning Compute, Data Science Virtual Machine, or Databricks. There are some guardrails, so if you are a data scientist, you already know some issues you might have with class imbalance in terms of the sizes, how you do the splitting, what you do with missing values, whether there are high cardinality features. That's going to be a feature that has many, many options, and whether you need to do one-hot encoding. And leaky features is when the feature inputs are somehow correlated with the output. So that's cheating. I call it cheating. Okay. Detecting overfitting, and then model interpretability. That's done through feature importance technologies. Okay, Azure Machine Learning and Azure Databricks. See that plus sign? These are not either or. Our messaging now as Microsoft is think about how you can use them together, because there are going to be some things in Databricks that are not in Azure Machine Learning, and vice versa, some things in Azure Machine Learning that you're not going to see in Azure Databricks. So there are going to be unique things. There's going to be some things that they do both, but there's also going to be some things that one or the others of these will do. You will be able to study these slides later, so I'm going to only kind of show them quickly, and then we'll go straight more to the examples. But the Azure Machine Learning service there. And then Databricks is an implementation for working in a Spark-based environment. It's built on secure, trusted cloud. An important thing is Databricks is integrated with Azure Active Directory. So that means the security and permissions are set through the Azure panel, and then they carry over into the Databricks environment. And then also implies how you use your data assets. So leveraging deep learning. So this Azure ML service will bring AI to the edge. This will be for rate of experimentation and deployment and managing models. The right side here, Databricks, is a great solution for Spark and integrating natively with the Azure services. How? Through Azure Active Directory. And then you'll have also the Azure security. Around what? Around your notebooks, around your data, and that's the important thing. And then down here for the data scientists, you're going to see all your popular libraries. And this is a representation. It's not a comprehensive list. It's a representative list. Productive services, what to use when. If you're a Python ML developer, you might want to do Azure ML service, building and training there and deploying there. I have a video on that, at least on the training. And we did it earlier for the Past Data Science channel. This was in March, and so that was what we had then. And then Apache Spark Big Data, you might want to do Databricks, and then choose some sort of deployment through Azure ML Service. Why do you deploy it here? Is because Azure ML Service is built to talk to the many resources that are available to Azure. So anything that's in the Azure world, like a container image, or container instance rather, or the Azure Kubernetes service, you would want that to be done that way. So what's new? These are some of the latest announcements with MS Build. Time series forecasting generally available. Okay, I see Nilesh in here, and so Nilesh, I'm now going to promote you to, if I can, I'm going to make you a panelist. Nilesh is in this presentation, and he wrote this blog post about time series forecasting. And Nilesh, hopefully you have your audio available. Let me see if I can turn your audio on. You can come off mute. Let's see. Nilesh, can you talk now?
Hi there. Yeah, I can talk. Can you hear me?
Yes. Okay, so
Awesome.
let me show people your face here from your page, which I already have prepped. I remember prepped for this here. There you go. Okay, so maybe you want to introduce yourself.
Hi there. Yeah, my name is Neil Shachari. I'm one of the program managers working on automated machine learning and focusing on forecasting.
Wonderful. So, and you also had this recent blog post here from June 6th, and would love people to read about that later on. And you'll also be available, you're going to be hanging on in the end for any Q&A. So I'm going to
Yes,
put you,
definitely.
yeah, so excited about that. Okay, so I'm going to put you on mute again, or you can mute yourself, and we will go back to the slide deck. Hopefully you'll stay on that slide, and we'll go forward. We also have automated ML and ML.NET, Onyx support. So this technology will consume an Onyx model, okay? We have to think about what the options are now. It'll run automated ML from SQL. Of course, here's a code. There's the QR code for that. Automated ML UI in Azure Portal, which is preview, which is what I'm going to show today. All right, so now we're going to do a demo with Azure Machine Learning Service. What I'm showing right now are slides. These will be in the slide deck. I decided to keep them there, and but we're still also going to see a live demo about making a new machine learning experiment. This is for Microsoft Azure environment, and I'm noticing here, you'll see the technology here showing the data profile, some of the information about the training, and then the actual runs, and then also what the results are. And each time here, it's in this case, it looks like it's going for normalized root mean square error. As it's getting results that are better, this line will drop. So this line drops, and this line drops. And as it goes across here, you'll notice here going up on the screen, this dot is above the other dot. So that's why it didn't have anything showing. It'll stay there until it finishes. So that's the idea. It's many runs here on the bottom, and the run status, and there's a dashboard. Now this is one that let's see, is this correct? This is the one I did? I think this is the one I did. So going across here, this was so the normalized root mean square error had a certain value, and then had a better one, so it dropped. So that's what that red line represents. All these runs here are higher, not winners, not winners. And then this one's slightly lower, maybe. And then, there's one that's definitely lower there, and then down here. So down at the end, that was the winner. So that's the idea. And you notice in the upper right, it's going to give you the opportunity to download the best model and deploy. So you can download it, you can deploy it. That's the idea. And then here's a zoomed in version of iterations that are running, shows you the name, the normalized root mean square error. One of the reasons I'm not going to run a full one is because it does take some time to do that. So we do not have enough time to do that, but you will see how to do that in the portal. So there's a web page that has to do with how to do this. And you look at the date here, May 1, 2019. So this is relatively new documentation. This automated ML. So here I am, and I'm going to check the audience view, make sure you all see what I see, and you do. And so now here I've made an Azure ML Databricks workspace. On the left side, I want to call out, these are preview. Okay, my concern for preview is when you put technology into production. If you're just using for development, you're probably okay. I'm not going to guarantee you're okay, but generally you're okay. So this automated technology, I would certainly think would be in a safer category, using it for development, and then deciding what you want for production. There are going to be future scenarios when one will want to use automated ML in production. Now is not the time for this technology, in my opinion, until it comes out of preview. So I would wait to make any production, unless you're going to be that person that doesn't care about that, and you're going to try it anyway. Okay, so but I like to keep especially corporate customers aware of potential risk on putting preview software into production. But for development, it's very cool. And so I'm going to click that link. It's loading. And what we see is I had done several experiments. One thing I experimented with is running the same experiment twice. This one experiment I ran and took 3 minutes or so. And I said I wanted to run it again, and I ran it in a 20-minute window. Let me see if it shows the results. Okay, so it does show the results. So this one had maybe about six iterations, and has that red line again showing that winners continue to draw that line down. But when I ran it longer, all right, so this is longer, and you can see it did all these things, and you set the time. You set the time for how long these experiments will run, and then it's just going to go through, and you can see here on the bottom with the iterations, it's going to go bam, 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 and you can see how long they took to run. This one's a demo example that I'm showing you on the screen, so many of the durations are like 1 minute, sometimes longer, sometimes they're 30 seconds. This one's 1 minute, 36 seconds. And then on here, I can download the model. And also, like it said, there's a deployment path. I'm not going to deploy right now because that's not the focus of today. And I see some questions coming in, so just continue to send your questions in. I'm not going to address them yet. Let me see what this one was. Auto ML classification. That one didn't get anywhere. All right, that did something. AUC weighted. Okay, in this case, we're trying to go up because this is area under the curve. So this is a reverse red curve. You can see as the iterations were better, it starts going up on the graph. And again, we can see an idea here about what these were automatically named and what the AUC weighted was in each case. And again, there's a deployment path, and I guess you can go screen to screen here on the bottom. You can see the different runs that were possible, and that's the basic idea. So let me take some of these questions. We're doing well on time. In the experiment, can we do snapshot data for point-in-time experiment for audit purpose? The answer will be yes. You will have to monitor your own pathway of that snapshot. The use case being that you want to make sure that you're comparing apples to apples. So you want to make sure that the data was used to train the model is the data that you're expecting. So I'm not going to get into how to do that, but I'm going to say that management may require your own clever ability to track that. If there is no automated way to do it, a way that I like to do that type of thing is to list the perhaps the data sets into a Azure SQL database, or you could put it into Azure Blob and have that available as the list that lines up specific days with specific snapshots. But managing the data for training the model is, I will say that is important. Second question here, I see that the default option for AutoML Spearman correlation versus iteration number is root mean squared, the preferred metric, instead of Spearman correlation. Okay, I noticed that too. I noticed that Spearman correlation was coming up first, and I don't know why, because Spearman correlation is a non-parametric method. You don't have to choose it. Just because something is in the box doesn't mean that's what you have to do. But let me go back here, and if I go to create experiment, this is what we're talking about. We're going to talk about, let me go to the first one. And I'm going to put on my CPU cluster. Because I know once you pick, wait, let me go forward. This one was Fairmount. All right, advanced settings. Aha, here we go. So I went This is just an experiment. I got the taxi fare data set. You can see the preview and the profile here on the screen. Then now it says classification. It's not a classification. This is a regression. So on the regression, what he's asking here is a primary metric. It shows its Spearman correlation. It's just the way it shows. You have to pick one, and that's just first on the list. I do not know why it's first on the list because it's not alphabetical. What I would pick is root mean square error, but you might want to pick another one. And I think as this technology improves, there may be other metrics that are possible to choose on the advanced settings. But you are not forced to choose anything. You can go under advanced settings, rerun this entire experiment again. Training time, job in minutes. Notice how defaults is 60. I didn't even use 60. Like, no, thank you. I'm going to use like 5 minutes. So I'm going to put 5 minutes, and I'm going to choose root mean square error, and that's the threshold. And then you have validation types. You notice you have choices here. Cross-valid. I don't know that I've used Monte Carlo cross-validation, so that's just an option. And any of these choices, there's an info box, and you can just click the info and see what comes. Now, right now, that's just a pop-up. Okay, so I was wondering, is that going to go to a web page or is it a pop-up? It's a pop-up. Okay, and then press start. So I'm going to press start. So this is actually taking an experiment I had already run. I changed parameters and I let it go. And even while this is, now I would not browse away from the screen while that's still processing, like on the screen there. But I think once it gets to here and it shows run preparing, I think it would be safe to go back, and if I wanted to start another round, and it would show it. So down here, so now this is true. The one that I just started, you can see still it's in a preparing state. When it was created, it hasn't even started yet, but now in the main panel, I can take even that same experiment, I can start another one based on that experiment. It's like, okay, that one's going to run for a 5-minute block using the RMSE, and then get that way. We had a question here, how does AutoML take care of data skewness? Web page I would go to is...
After that one?
Yeah, you want to do it?
Yeah, sure.
Because I was going to go to documents. Go ahead.
Sure. So basically, a part of automated machine learning, we do actually do some checking and skewness and normalization and trimming of the data. So it's a part of some of the steps that we do just to make sure that the data is in a good shape before we start training. And so we're doing those checks beforehand, but we'll continue to make investments there, as you heard about some of the guardrails. Yeah, it's some of the checks that we do already.
Okay. And those are in the documents here. Is it in the ML.NET documentation, or is it somewhere else?
It's in the Azure docs. I can send links afterwards.
Okay. And can AutoML handle deep learning? I'll let you answer.
On our roadmap. So that's something we're investing in the coming months.
Okay, coming months. So we have it official there on a roadmap. I do not promise a roadmap because I do not work on that team. Where can I find sample data? So the answer for that is you can get data from anywhere. What I did in my case is I just uploaded data that was available, and I think I got it from, I'll tell you where I got it from. There was the ML.NET has some solutions that are in Visual Studio, and they're related to the talk I did yesterday, first session. And I showed that yesterday. I took that data set that's on the GitHub repo for ML.NET, and I used that as my my test data. So you could always reproduce any experiment. I mean, I took it from ML.NET. You could take it from any experiment. Wherever you have data and you're able to get it into like that CSV format, try to come in here and then replicate the experiment.
We also have samples on our GitHub repo for automated machine learning. Again, I can send links for that. And if you want to replicate the notebook samples for the UI, you can use those data sets as well.
Okay. Can you put that in the chat?
Yeah,
Yeah,
sure.
down in the chat window. Okay, and then just put it to the entire audience. Okay, so great question for sample data. That's also one of the ways, if you're already doing data science, then I would recommend, if you want to getting into this technology and see what it does, try getting a data set that you've already used or something that you've already seen in another context, bring it here and see how it does. You'll have to know what it's doing, like regression, classification, or whatever. But and then you're probably going to want to use the one that's fairly clean already. It's not going to have a lot of ETL happening for that because you're not getting the ETL opportunity here. It's just load the data and go ahead and run it. Let me see what's happening now with the one I just started. It's still preparing, and it could be maybe because the compute's still coming up. I don't know if it shows here. Let me go to compute. I think it does show. All right, so these are the computes I have to choose from. And I don't remember if I set them up or they were already here, but the one I used for CPU cluster, this is what, actually this is still in preparing state because it's getting ready to run for the experiment that I just kicked off. Shows that the maximum number of nodes is 2, and idle second before scales down is 120. So this compute, once it spins up, it'll run and it'll have maybe a maximum number of 2 nodes to run those experiments, and then it's going to power down. Power down is a good thing because data scientists are going to forget. Forget to turn off your machine. This GPU cluster that I made is based on the NC6, and here it has the maximum number of nodes too. And again, this is just really for doing demos. And so that scales down to after it's done. So separates the compute from the run. Is there any connector to read in Cosmos streams, Azure Blob, and Azure SQL? Go ahead.
Azure Blob, yes. And SQL, we have actually worked with the SQL team to do an integration so you can run automated machine learning directly on there. And then I think the third one was Cosmos. You can do that through Data Factory and push your data that way.
Okay, so those are your answers. Okay, thanks for the links to the repos. Thank you for that. Here it is. This is for automated machine learning from SQL Server with Azure Machine Learning. So there's a blog post on that. This is from April and on the SQL Server blog. So again, very similar, that line that we talked about, just idea of how to do that. Okay, let me go back to the deck. Okay, now we're going to do Databricks. Databricks is a managed Spark offering in Azure. Customers already use it for advanced analytics. Provides collaborative notebook-based environments with CPU or GPU-based compute cluster. You set your cluster up, whatever, and in fact, multiple clusters can be set up or described. And then collaborative, meaning that the team can work together. Now that I'm thinking about it, we need to be over there in the window because I need to turn it on. So I'm going to be in Databricks right now. I'm actually going to go to my cluster and make sure that my cluster is running so that by the time I want to use it, it will be here. But let's look at what it is. This is the Databricks portal. These are some of the little circles on the left side. This cluster here is, I set it up with the, I forget where it was being suggested to set up a high concurrency model, but that's what I set up. It's not the only way to do it, but this is the way I did it today. And then I ran Databricks 5.4, Python 3. These are standard DS13 V2 with 8 workers. So that's what I set up for my cluster. Again, this is a video, so you can go back and look at this screen. So while that's spinning up, let's go back to the deck. The Databricks features, customers who use Databricks for advanced analytics can now use the same cluster to run experiments with or without automated machine learning. So this is not a requirement, it's an option. So option is to use that technology. You may keep the data within the same cluster. You may leverage the local worker nodes with the auto scale and auto termination capabilities. You may use multiple cores of your Azure Databricks cluster to perform simultaneous training. You may further tune the model generated by automated machine learning. So you can do some further tuning. Every run, including the best run, is available as a pipeline, which you may tune further if needed. And the model trained using Azure Databricks can be registered in an Azure ML SDK workspace, which is what I was showing earlier. That is the workspace. And then deployed to Azure Managed Compute, which is an Azure container instance, which would be one, or Azure Kubernetes service, which would be a lot, using the Azure Machine Learning SDK. So that's a lot to ingest, but we can see, some of the features that would draw people toward this technology. There's a GitHub demo, and this is the code for the Git QR code for that. Again, this will be in the deck, so if you want to shoot it now, bam, you can be right there on your mobile device. And how to configure Azure Databricks is the tricky thing. Okay, it's tricky because it's different. I've done so many Databricks things, and this was yet another new challenge, how to connect the library to the proper cluster. Okay, so now I'm going to go back to the screen showing the demo. Let's go there. Okay, this is still coming up, and I guess it doesn't have the library. I will when it gets going. So let me describe what I had to do. And this is not a introductory Databricks talk, but I'm going to show you that I added two libraries here. One is called AutoML Databricks. And what is the library? A library is just code. And this one came from PyPy. So that was where I got that code. You can see here it's pending on the cluster, meaning it's going to be loaded. Okay, there's a second one here that's just called Databricks. And it doesn't say AutoML. It's a different one. It's just for using the Azure ML SDK. The one we care about right now is this one, and that is the AutoML Databricks. The notebook that I have here, there's several notebooks that just have to do with Azure ML, but the notebook we're going to focus on is called 6. Automated ML on Databricks. And right now, there's a little spinning, it's hard to see on your screen, but it's a little spinning icon there, and it shows that the cluster is still spinning up. So I'm not going to run it right now. We'll just read through this. This has already been run as a notebook. And then if we have the opportunity, we'll run it. But in this notebook, it shows how to create an Azure Machine Learning workspace object, create an experiment, configure it, and train the model and explore the results and test the best fitted model. This is what a data scientist would want to do. So this is where you get your library. You have to load it through loading a library. I'm not going to show how to do that now. In the notebook here, it says when attaching library, follow this link and then add the below as a string. Let me see if that'll open a new window just to see where that goes. Okay, it goes to libraries and how to do that. And this is the Databricks documentation, general documentation for libraries. And the reason that has to be added is because the package is not on the cluster. The cluster has things on it. It does not have this package. So that's why it has to be installed. Check the Azure ML Core SDK version to validate your installation. Print it, and it shows here 1.0.43. And this is still starting. One thing I noticed is that when I was running this notebook, the first time I would run it, it would give me a bunch of warnings, and then it would show SDK version 1.0.43. Then, when I ran it the second time, it didn't give me any of the warnings, and then it showed SDK version 1.0.43. I'm saying that now because you might see that when you run it and wonder what all these warnings are. And I would not do a run all, by the way, on these notebooks. I would just run one cell at a time and go through and make sure that you are confident about what this is doing. Second thing here is about initializing the Azure ML workspace. Now, what is an Azure ML workspace? Let me go back to explaining that. When I made a resource group called Azure ML Databricks, inside it already has a Databricks service, but this workspace did not exist before I made one with the code. Once I make one of the code, I do not need to make it again. So if I'm going to rerun this notebook, I do not need to make another workspace because I already made that. That is the workspace I showed earlier when I went to automated machine learning, and probably still have my experiment is running. So it's running right now. I use that same workspace. So we update some variables so that a new workspace can be created, and that's what this creation of workspace is. One of the things that it will ask you to do, it will probably ask you to do, is go open a web browser and put the code here to authenticate your device. It's an extra layer of security so that people cannot just simply run off of your subscription. They will have to be connected to where you are, device-wise. Configuring a local environment, and so that's what this does is it makes a configuration file that allows this session to run with that workspace. In other words, to talk to that workspace back and forth. I see in the top the AutoML cluster has come up, and that little lightning bolt means it's active. Down here, it's now going to have creating an experiment, and you'll see some of the main common libraries that one will see in Python listed there. It'll get the workspace information from that configuration file, and then it starts working on, showing you some information about where this is running. So these are parameters that I set. I happen to be in the US, so I picked a US location. You do not have to pick the US. You can pick a location where this technology will run. Not all regions have every technology. There is a master list on the main page, showing what services are available in different regions. Diagnostics. So that's a feature to turn on. Load data using data prep. Now, I'm going to read what this says. Automated ML requires a data flow which is different from data frame. Data frame is what you know. Data flow is what automated ML needs. If your data is in a data frame, please use read pandas data frame to convert a data frame to data flow before using dprep. So that's just a note. So this now will access a package. And you can use auto read file, which intelligently figures out the limiters and data types of a file. Again, as many of you know, Python will have a lot of ways to automatically determine schemas. You can either be happy with it, or you can tell it what the schema is, or afterwards you can make it the way it needs to be. So any of those three. In this case, it's removing the header row. It's one of the lines. Then let me read what it says here. Okay, and it talks out here about converting column types, which is along the lines of what I just said. The type might not be correct. Reviewing the data preparation result. Now, down here, you're configuring the AutoML about what it does. Just as in the automated panel, I'm also able to choose how many minutes. And remember, we had the question earlier about the Spearman correlation. Here's where you choose a metric. So, that's right here. This metric, this primary metric list is for classification. The second one is for regression. That's the difference between these two lists. So you can choose it. Just because Spearman is first on the list doesn't mean use it. I know a lot of people is like, oh, first choice. Well, you have to know what one you want. The choices here mapping to what we also saw on the automated screen. You make those choices, then you train the model, and then you see very similar to the other run. What I noticed in this run is that it's only showing the first so many, but it didn't really show all the ones that I did because there were actually more. So let me see if that page is still there. I don't know if it will be, but we will see. Let it come up. And it is still there. So let me tell you what I mean. On this short printout, it showed that the highest one was iteration 7. But when I went to the other panel, 7 was pretty good. Let's see, where was 7? 5, 6, 7? But there were a lot of runs in here that were higher than that. I don't know why those don't match up, but I always like to look at the full list anyway. So in this case, 29 was the best, and I think that's when I just timed out of the experiment. So that's as far as I went. I can run it longer, you know, and you can see the iterations go further. But what you see in the box here when it's running, you just see processing, and then at the very end, it will have the ability to track that experiment. Here, retrieve all the child runs once it's completed, and it has it into its matrix. This matrix, because it's in a data frame now, this data frame summarizing the experiments can then therefore be output to something else, just letting you know. Retrieving the best model after the experiment is completed. So this is where you pick the best one. And the best model based on any other metric after the above run complete is based on the child run. So this is going to pick a best model based on a different metric, which is log loss. So how do you pick the different model? Because you already have all the models there. The one that shows on the graph is the metric I picked, which is AUC weighted. But you say, all right, I want to do log loss, and you can go get that one. Test the best fitted model, testing out the model. This one is for the MNIST data set, it's really hard to, if you've never seen MNIST, you're like, what are we looking at? It's supposed to be a digitized image of somebody writing the number 3, and the predicted value is 3. So the actual value there is 3, and the predicted value is 3. And then here's a box here for deployment as a web service. So that's the last thing there. Okay, I had a question here, so let me go back to the questions. That is what I want to show for the demo. In fact, let me go here. Enterprise scaling, because this may answer some of the questions. To deploy them at scale, you may want to use some of the other technologies that are in Azure for that purpose in Azure ML Service, which are based on containers, Azure Container Instance, or Azure Kubernetes Service, which is where you want to go. Model deployment. And make sure I'm going to check the audience view. Okay, good. You had heavy edge, light edge as options. There are Azure reference architectures that talk about generally how to use Azure resources together. And I recommend this page to get some ideas. Your action steps here are to try this for free. And you see the link here, AKMS, AML free. You got more here, the docs, the notebook samples, the blog posts, and product feedback. I would certainly love to learn more about what you think about that. I'm going to start answering the other questions. So we'll have some more questions here. Let me see. So Nilesh might want to answer ones I don't know. Can it handle categorical data? Yes, because there's classifiers. Next question, don't see the repo links that Nilesh posted in the chat window. Did he post for presenter only? Okay, let me see that. I don't know the answer to that. Nilesh, the repo, is that one of these links here, or is it a different one?
It's a GitHub link on that slide. I don't actually see the screen share for some odd reason, but I know that slide, so it's on there.
Okay, so let me go to the other screen. I think I have that up. Oh, I got too many windows. Not in Nimbus ML. We're not there anymore. We're done with that. Done with that. We're just gonna have to close windows here. It's called Find It by Elimination. It's definitely in a Chrome window, or maybe I didn't open it. But that's going to be GitHub for AutoML, right?
Yeah, it's GitHub/Azure/machine learning notebooks. If you go there, and there is a subfolder for how to use Azure ML, and then there's a subfolder for automated machine learning.
GitHub, sorry, again?
Yeah, github.com/Azure/machine learning notebooks.
Okay, so that's where you want to go. And this will be on the, this is now on the video, because everything we're doing is on the video.
Perfect. And then there's a folder that says how to use Azure ML. And in there's a folder within there that says automated machine learning. And then there's all the samples.
Woohoo! Look at that. Some of you might have something new to do this weekend. Because I know some people just love technology and just want to try new things. So there you go. Lots of new things to try. Can we deploy a model trained in Azure Databricks using H2O sparkling water library in AML service? That's an advanced question. Now, do you have an opinion on that?
No, I don't know the answer to that one. I'll have to take that one and check.
Okay. On the question, so now I should have a separate question. I've been pointing people to Gitter for ML.net, but where should they ask questions about automated ML?
They can send an email to Ask Automated ML, and that'll go directly to the right teams here in the product team, and we'll find the right answer.
Okay, so there's your answer for that. When will AutoML go GA?
AutoML is already GA.
Okay.
The SDK is already GA. The UI is in preview, so if you're using the UI, that's probably what you're seeing the preview tag on, but the actual service, the SDK, is all GA.
Okay, thank you. Code be shared later. Code will be on it's linked in the slide deck. This is all for Python. Do we have anything for our model deployment?
Nothing yet.
Okay, that's the answer. The answer is nothing yet. Okay, so thanks everyone for, oh wait, let's see. Can we get any support at the project level? I'm going to say that depends. So let me answer that question. If you are working with one of our account teams at Microsoft, then that will be the way to get help for particular projects. If you don't know who that is or might be for your organization, you can contact me offline. I'm not going to answer specifically, and I'd have to look it up anyway. Another way to go forward is also to work with our partners. We have so many valued partners in this space that know this technology, and that's another way to get some project help. But that's an outline of the answer. Someone also asked, is R supported? And I think the answer was not yet. Was that the correct answer?
That's correct. That's correct.
Okay, the answer is not yet. All right, so folks, thanks for attending today, and thanks, Nilesh, for your support in answering some of these questions. Certainly, I know the team would love to hear your feedback, not just feedback of questions, but if you have success stories, we are very, very interested in learning those. If you have use cases that we haven't thought about, or things that you see similar products doing and just wondering, will this technology do that? Let us know, because we want to know. And we're always interested in helping you achieve your solution and answers. So this is the end for today's presentation. I'll be stopping the recording.